Today we're diving into one of the most ambitious backyard projects you'll ever see. After more than a decade of planning, our determined builder finally begins connecting a bunker built 12 years ago to his house with a secret underground tunnel. Inspired by the Great Escape, he proudly names the passage Tunnel Dave, giving a modern nod to the legendary escape tunnels. Luckily, the neighbors only see a guy who's really committed to landscaping. The adventure starts with careful excavation. As the earth is removed, sturdy steel sheet panels are installed around the tunnel to prevent cave-ins and keep everything secure. Stainless steel rivets lock the panels together, turning loose soil into a surprisingly solid underground corridor. Every step reflects thoughtful planning and impressive engineering.
I know what you're going to say. Pot rivets holding soil, and these are stainless steel pot rivets. They're not just the weakest thing out there. And there's a lot of them around the flange. That's it. That's as far as we're getting in this video. We've done 2 foot.
To tackle the digging, the builder creates his own tunnel boring machine, instead of spending a fortune on commercial equipment.
Let's go in.
Built from recycled materials, the homemade machine features heavy-duty swinging arms that pivot in every direction, making it easier to guide through the cramped tunnel while supporting the weight of the cutting head. It's proof that creativity can sometimes outperform a giant price tag. The project becomes even more impressive with a custom-built tunnel cart and lift system. Old parts, including a discarded treadmill that now serves as a conveyor belt, are transformed into practical equipment that carries soil out of the tunnel. It's amazing what can happen when someone looks at scrap metal and thinks, "Yep, that's construction equipment." History and innovation blend beautifully throughout the build. While Tunnel Dave honors the daring escape tunnels of the past, it also showcases modern DIY engineering, powered by patience, welding skills, and plenty of determination.
It's just pure sand at the moment.
Of course, underground construction isn't all smooth sailing. Water begins seeping through the soil, slowly turning sections of the tunnel into an unwanted indoor swimming pool. Pumps work around the clock to keep the excavation dry, but the deeper the tunnel reaches, the tougher the battle against groundwater becomes. To maintain stability, more steel panels are installed. While excavation methods shift from mechanical digging to hand-operated drilling, where greater precision is needed. The tunnel roof is carefully shaped into a dome, allowing the surrounding earth to naturally transfer pressure toward the walls. It's a clever engineering technique that greatly improves long-term strength. As the tunnel grows longer, the physical demands increase. Digging from above proves just as exhausting as working underground, especially through dense, compacted soil. Yet the builder never cuts corners, reinforcing each section before moving ahead. Finally, an electric railcart is introduced, making it much easier to haul countless loads of excavated dirt. With every trip, the project moves one step closer to transforming an ordinary backyard into an extraordinary underground masterpiece, built through skill, persistence, and remarkable craftsmanship.
Is it digging all right?
They then pushed up, broke the turf, broke the surface, and had a good look.
This is sticky, wet mess. Get in there. And another. That nearly went in the tub, didn't it? 20 trips later, I've done.
With the bunker taking shape, work continues deeper underground. More drilling is carried out to break through compacted soil and expand the tunnel safely. Every swing and every hole drilled is carefully planned, because underground construction leaves very little room for mistakes, or for standing up straight.
Tunnel with any weight on it. Maybe I'm wrong. Hopefully now we can hook this on here. Hopefully it'll fit. We're ready to do a test run.
Next comes the brains of the operation, a fully programmable speed controller. Top speed, acceleration, braking, and even regenerative braking can be adjusted. In other words, this secret tunnel now has better electronics than some scooters. The project now enters one of its most important stages, the construction of a brand new underground bunker. Using an excavator, the builder carefully digs the site to the exact depth needed for a solid foundation. Precision is everything here, because even underground, a good build starts with a strong base. Once the tunnel finally breaks through into the new space, attention shifts to preparing the bunker foundation. The ground is compacted thoroughly to remove air pockets and create a firm surface capable of supporting the massive structure above. After that, steel reinforcing bars are cut, bent, and tied together into a strong grid that will become the backbone of the concrete slab. Concrete is poured evenly over the reinforcement, carefully leveled, and left to cure until it reaches maximum strength. Every stage is completed with patience, proving that rushing concrete is about as smart as sprinting on wet cement.
All right, John.
Next, vertical reinforcement is installed for the bunker walls. These steel bars give the concrete the strength needed to resist ground pressure and long-term movement.
I think we'd be better off with some weld as well on it. Hold it together a bit stiffer. That's nice, isn't it?
Around the tunnel entrance, selected reinforcement is trimmed back to create a clean opening while preserving the surrounding structure. Strong formwork is then assembled to shape the walls before concrete is poured.
Well, I'm glad you stopped.
As the forms fill, the concrete is vibrated to remove trapped air and ensure every corner is packed tightly. Once cured properly, the finished walls become a durable shield capable of standing up to years of underground conditions.
She is looking good. Tunnel entrance.
To improve drainage, gravel is placed around the outside of the bunker walls before the excavated soil is carefully returned. A large steel reinforcement mesh is then spread across the floor, completing the preparation for the next concrete slab.
Come across here. It's not looking bad really. So there's a drainage channel all the way along there. This is a jetting hole here. So effectively that's going to be in the brickwork like that.
Attention now turns to building a beautiful tunnel arch. A custom metal template is fabricated to guide each brick into a perfectly curved shape, creating both strength and classic tunnel aesthetics. To keep the project moving despite unpredictable weather, a protective tent is erected over the work area.
It's not too bad really. They're mega heavy, they're not like the normal bricks. Because they're solid. Pick that out there. All the water would be running down here. It'd be horrendous. Last Friday, building this tent was the best thing I've done lately. So these top bricks are in place. You see my guides underneath, can't you? So they've got, that shows you the brick and then the mortar.
The builder also fabricates a heavy-duty steel staircase that provides safe access between levels.
It's worked.
Then comes a memorable surprise. A beautifully restored 1944 military Jeep is lowered into the bunker, adding a unique historical centerpiece that's guaranteed to make visitors stop and stare.
Obviously from now onwards we've got to do that bit in there, one bit, join it through. This is that tape that joins it all. That's all the 100mm insulation in all that area. Just this bit to go now. All been taped around the corners, putting staples in. But he's made an amazing job here. think they're making a fantastic job for a bit of handwork they've done underneath there for the fridge look. Screed floor done. As you can see from the time lapse, we'll put all these beams in now. We'll put one block each side to space them, get all the beams in place for the digger. Looking good. Here's the end result, look. Then it was a satisfying job of putting all the blocks in place. They just literally push in place, dead easy, quite heavy work. So before I put the floor in, I had one job, and that was to put the step in.
Just when everything seems ready, another challenge appears. The existing tunnel sits slightly too low to meet the new bunker. Rather than accepting an imperfect fit, the builder carefully dismantles part of the tunnel without temporary supports, a task requiring remarkable confidence and precision. Using timber blocks and ratchet straps, the entire section is slowly lifted and perfectly aligned, proving once again that patience and craftsmanship can overcome even the toughest engineering obstacles. Water management becomes the next priority. A specially designed sump system is installed to collect both groundwater and any water entering the tunnel. To fit the system perfectly, extra excavation is completed until the depth and alignment are just right. One tunnel section had even been prefabricated with an opening ready for the sump, showing just how much planning went into this remarkable project. The cavity is then filled with pea gravel, allowing water to drain efficiently while keeping the system protected.
As I showed before, the floor was really wobbly, but by filling all the little cracks in with cement, it locks all the floor together. Well, I hope so anyway. But it has seemed to have worked, to be fair. So we have a bunker. You know, I started digging this end of June. I've not really thought about anything else apart from this bunker since then, but we get back in this corner. It is looking good. Obviously the wiring's to redo. That's only temporarily done just so we can see in here. Well at all, because as I weld, this tries to put the rivets up.
Attention now shifts to security, with the construction of a custom steel tunnel door. Thick steel sheets are precisely cut, while the initials TD for Tunnel Dave are crafted from the same material and proudly mounted on the front.
Looking good. So we've got the hinges here now. So I use the tab and slot function on SolidWorks.
It's not every day you see someone giving their secret tunnel its own logo. The door mechanism is just as impressive as its appearance. A hand wheel operates a chain-driven gear system that controls the locking mechanism. Carefully positioned gears rotate together, allowing both sides of the door to move in perfect synchronization.
After the slight bit of trimming, that's looking better. I'll just go upwards now. Yeah, this is as heavy as it looks, I can tell you that now. Fit. I've adjusted the door, which took forever. I put my new wheel on, but that's it.
One side locks securely, while the other pivots on heavy-duty hinges, creating a system that's both clever and reliable. The finished result looks less like a DIY project and more like something from a high-security movie set. Then comes one of the most ingenious features of the entire build, a fully functional log burner that secretly hides the tunnel entrance. Weighing close to 100 kilograms, the massive stove is mounted on heavy-duty hinges, strong enough to support its weight, while allowing it to swing open smoothly. Laser-cut steel components provide exceptional accuracy before every section is welded into a durable structure. Decorative details give the burner an authentic, handcrafted appearance, while a heat-resistant glass window lets the fire glow safely inside. A rolled steel pipe is welded tightly to the burner, creating an airtight chimney system capable of handling intense temperatures.
I want to light this fire.
Behind the scenes, an L-shaped steel plate supports the burner, while also protecting the surrounding wall and floor from heat damage. Heavy-duty hinges allow the entire assembly to pivot, quietly revealing the hidden entrance whenever needed. Perhaps the cleverest engineering challenge is the rotating chimney. Specially fabricated pipe sections allow the chimney to turn together with the swinging burner while remaining properly connected for safe smoke ventilation. It's such a seamless design that you'd never suspect an underground tunnel was hiding behind what appears to be an ordinary fireplace.
We've done the bathroom to start off with so we can get the toilet fitted, sinks in, look, and the saniflow unit at the back. So we are at this important point now. We need to turn that on. Oh yes! So we've now got hot and cold on the outside of the taps, working in the sink, which we pull the drain out, obviously goes down the pipe, into the saniflow unit, and then when that gets to a certain level, pumps out like that. I know I should have started at the back corner of the room, not this edge here, but the reasoning behind that is, why did I do that, Dave? Because I had to do the toilet first because Heath was fitting all that plumbing, and he's finished now because I've had him for like nearly a year. So as you can see, I've got the tiles down up to the last row now. The last row already trimming.
With the mechanics finished, attention turns to the details. Flooring is secured, edges are cleaned up, and the tunnel entrance is tidied until the entire underground route looks surprisingly polished.
And the upstairs room above it, which is the manifolds here, which meant I've got a load of leftover pipe, so we can use that for a little job.
As if that weren't enough engineering for one project, the builder sets his sights on the next upgrade: a remote-controlled tunnel cart capable of traveling forward and backward with built-in speed limits. Because even secret underground railways deserve responsible drivers.
Central heating pump, I think it is. Got 2 bits of copper, off cut, left over. Put them in there. That just pushes on there. So the brown is the live wire. Push that little trap door. So we need to connect the radiator. So where do we want to connect this? Heat rises off the radiator, so is that what we want? Do we want the heat to go to the top? As I stand on the tunnel cart.
For the final stage of the build, Tunnel Dave gets a serious upgrade. The cart chassis is fabricated from 3mm galvanized steel, while wheels and other parts are cleverly salvaged from old equipment. Custom gears are cut from 2mm steel, held in position with magnets, then welded and bolted together. It's recycling, but with sparks flying everywhere. A drive cog is welded onto the shaft, a double-wheel hub is assembled, and the axle is precision machined on a lathe, giving the tunnel cart a much more professional setup.
Let's do some drilling.
After countless hours of digging, welding, and problem solving, the project finally feels complete. But one challenge remains: cooling. Ventilation alone isn't enough, especially when friends visit the bunker. To solve this, the builder plans a well-fed air cooling system that will deliver colder air underground.
Brackets look great. This is all right. I didn't want to use this pipework. I wanted to use the proper galvanised pipework, but actually, I don't know, it sort of looks all right. So why have I done it in 6mm plate? Because on the proper Jeep, this is all flared over and rolled round, and I can't do that close together without a full-on press tool. We're not making a full press tool for one front panel. So we'll just add a thick metal. It'll give that same impression that the Jeep's got.
The iconic Jeep front panel is also modified to house the new intake system. Using 6mm thick steel, the custom grille is built tough, because apparently, even a secret bunker deserves a rugged automotive makeover. And with that, this incredible backyard tunnel transforms into a fully functioning underground hideout, part engineering project, part movie set, and 100% dedication.
One's here, so let's just guess. Black to red.